Hi there, welcome to skill 2.2, which focuses on isosceles triangles and equilateral triangles. So our essential question for today is going to be, what are the special properties of isosceles and equilateral triangles? You might have heard of those words before, but there's characteristics about each of them that come into play when solving for unknown angles in many different types of pictures, and we're going to look at some of those today. So take a minute, copy your essential question down, and again, remember that's what, by the end of this video, you should be able to answer. So it says in example 1, given the isosceles triangle below, explain why the measure of angle 7 is 136 degrees. So they're telling us what angle 7 is. We have to note that we have to go back and explain why though. So meaning we have to write some sentences. But they also use this vocab word here, isosceles triangle. All right? So the first thing we need to know is what's special about an isosceles triangle. And the special properties that it has is that it has two congruent sides. And because it has two congruent sides, it also has two congruent angles. All right? So those are your two special properties about an isosceles triangle. It has two congruent sides, which makes it so that it also has two congruent angles. So the first thing we're going to look at is, notice that our picture here has these hash marks on them. One here and one here. Remember that the hash marks designate congruent segments. So this top side here of our triangle is congruent to this bottom side here of our triangle, hence it being an isosceles triangle because it has two congruent sides. When it has two congruent sides, we said it forces it to also have two congruent angles. And it's the angles that are across from those sides. So if I stand at this top hash mark here and look across from where I'm standing, I'm going to look at angle 5. And if I stand over here at the bottom side that was congruent and look across from it, I'm going to see the 68 degrees. So those two angles then must be congruent. They have to be the same measure. So if this top angle here is 68, that means that angle 5 is also going to be 68 degrees. So that's the first sentence I'm going to write down because that's something new that I did not know when I started this problem. So the first thing here, the measure of angle 5 is 68 degrees. My reasoning for that, so I can say because isosceles triangles have two congruent sides and two congruent angles. So that's step 1. We identified our congruent sides, and from there we identified the angles that were opposite of them, and those two angles are always going to be congruent if you have an isosceles triangle. Now if we go back to our goal though, we're looking to eventually prove why angle 7 is 136 degrees, excuse me. Well, angle 7 is over here on the outside of my triangle. So I can't figure out what that is just yet, but thinking back to the last video, we said that angles in a triangle have to add up to 180. And if I look here, here's my triangle. I now know two of my angles are 68. So I can go ahead and find the third angle, which is going to be angle 6. So in looking at that, all right, off to the side here, I'm going to do a little bit of work. I'm going to take 180. Oh, I didn't mean to write in that. Hold on. Let's go back. All right, let's go back to my pen. So 180 minus 68 minus the other 68. And when we go ahead and subtract those, we're going to be left with 44. So the second sentence I'm going to write here is that the measure of angle 6 equals 44 degrees since angles in a triangle add to 180 degrees. So 68 plus 68, added those up, subtracted it from 180, we're left with 44 degrees. So I now know that angle 6, this angle right here, is 44 degrees. And now I'm left to figure out what angle 7 is. And again, if you think back to that last video that we talked about, angles on a straight line have to add up to 180. Well, 6 and 7 are on a straight line. So if I know what angle 6 is, I can go ahead and find what angle 7 is, again, by subtracting from 180. So 180 minus the 44, this time I am in fact left with 136. Again, if you get a number that's different than 136, please go back and check your math. It might just be a calculation error. Maybe you just happen to jot down the wrong number. But I need to finish my work here with one final sentence because again, it had that keyword explain. So our third and final sentence, the measure of angle 7 equals 136 because angles on a straight line add to 180. And there you have it. So something to just keep in mind here, and we've seen this in the past with Miss Griffin and I, a lot of times students will do all their math, they'll find all the angles correctly, but they would only end up writing this last sentence here for the explanation, and then it actually does not get you full credit. Full credit in these types of problems means you have to explain each and every step along the way. So please keep that in mind, and that's why you'll see us writing so much here, because everything that we write, you essentially also have to write down if you want to get full credit. So first big idea for today, isosceles triangles. They have two congruent sides and they also have two congruent angles. We're going to take a look at the example on the back here, which probably involves an equilateral triangle. So here we are, example 2, and it says given triangle ABC with the measure of angle BAC of 60 degrees, BD is drawn perpendicular to AC and DE, such that DEB is an isosceles triangle with BDE is 30 degrees. Determine whether DEC is scalene, isosceles, or equilateral. Explain your response. So that was a whole lot of vocab there in one simple question. I'm going to go back and take it one step at a time, either jotting down the information that it told me or marking my picture up with whatever else it said. So the first thing being, it says measure of angle BAC is 60. So thinking back how we find our angles, I start at the first letter B, I go to the second letter A, I go to the third letter C. So this angle that's right here in the middle, that's going to become my 60 degrees. The next sentence talked about perpendicular. So thinking back, perpendicular means 90-degree angles. Two lines that intersect to form right angles, and we know all right angles are 90 degrees. So notice that there's already that red box there, and that red box denotes 90 degrees. So you could also write a 90. I'm going to leave the box just so my picture doesn't get super messy. And then it also then said that DEB was isosceles. So thinking back to our last example, isosceles means two congruent sides, and it says BDE is 30. So if I follow that, BDE is 30. So this angle over here is the one that's going to be 30 degrees. Determine whether DEC is scalene, isosceles, or equilateral. So I'm going to first outline that triangle so I know that that's the one that I'm focused on in this problem. DEC. And we want to figure out if that's scalene, isosceles, or equilateral. So let's talk about what each of those vocab words mean, because at this point we've only talked about isosceles. So if we start with scalene, though, I'm going to use the page or the column here off to the left. Scalene triangles. I'm in the highlighter again. Hold on. All right. So scalene, S-C-A-L-E-N-E, scalene triangles, they have no congruent sides. So what that means is that all the sides are different lengths, which would also cause it to have all different angles. So none of the angles are going to match up. We just talked about isosceles. This is a hard word for everyone to spell. I-S-O-S Isosceles triangles. We previously talked about that has two congruent sides, which means it also has two congruent angles. All right. So the last word that we're left with there is equilateral. And actually, equilateral should be familiar because we talked about this in Unit 1 with the constructions. Equilateral triangles have three congruent sides, which then means it's going to have three congruent angles. So all the angles would have to be the same. So knowing that piece of information, we're going to have to figure out what all the angles are in DEC, and then based on that, does it have three angles the same, two angles the same, or no angles the same, and that'll allow us to pick which of the vocab words is best for this problem. So at this point, I'm going to take what we have and see if we can start figuring out any of the other missing information to eventually allow us to figure out what kind of triangle DEC actually is. So we marked up the 60 degrees with BAC. We drew in, the right angle was already labeled for us. If I go to the next piece of information here, it talked about how DEB was isosceles, and we know isosceles triangles have two congruent sides. So looking at triangle DEB, that would be this triangle here. I know that two of those sides have to be the same, and two of those angles have to be the same. Well, E up here is the middle letter, okay? So that's going to be this angle over here. And I don't know what that angle is yet, but in looking at the picture here, it doesn't necessarily look like it's going to be 30 degrees. And if I had to pick my sides that were going to be congruent, it's going to be BE and ED. A problem will typically say what sides are congruent, so that way you know for sure. But in this case, I'm going off of that middle letter there being E, so that means my sides next to E are going to be the congruent sides, which then means, if you think back, my angles that are across from them are going to be congruent. So across from that top purple mark that I drew was my angle of 30 degrees. And across from this bottom purple mark that I drew over here means that that angle up top also has to be 30 degrees. So I'm going to jot that down as our first piece of information that we did not know before. Let me get a color here. All right. So that would mean that the measure of angle, now I can't call this up here angle B because it's just the right side of B. I'm not talking about all of angle B. So I have to use my three letters and make sure B is in the middle. And I'm going to call that angle DBE. If you want to call it EBD, that's also correct. But I'm going to go with DBE is 30 degrees. Since isosceles triangles have two congruent sides and angles. That's how we figured out that other angle was 30 degrees, and it was because of that vocab word there. So I'm going to go ahead and write in that 30 degrees. So sticking with that same triangle, I now know two of the angles are 30, so I can actually go back now and find what this angle over here is, again, with the fact that angles in a triangle have to add up to 180 degrees. So if I take a little side note here and do some math, 180 minus 30 minus 30, those 30s add up to 60. 180 minus 60 is going to leave me with 120. So this third angle in my triangle is going to be 120 degrees. So I didn't know that before, so I got to write a little sentence as to how I figured that out. So the measure of angle, again, I have to use three letters here. I cannot just call that angle E. I'm going to call that angle BED because that follows the outline of that angle with E in the middle there. So BED. If you called it DEB, that's also fine, is 120. And if you think back, our reasoning this time was because angles in a triangle equal 180. That's how we figured that out. So all that information is wonderful, however, I still have 0 angles inside this orange triangle that I'm trying to actually find. However, since we just figured out that that angle there was 120 degrees, I can now figure out what this angle right here is. And you might be saying, well, why? Think back. I see a straight line. Angles on a straight line have to add to 180. So if the top part of E here we just said was 120, well, 180 minus 120 means that this angle over here is going to be 60. So I can go ahead and name that angle as well. Again, 3 letters. I'm going to call that angle, I could go CED or DEC. I'm going to go with DEC. If you picked the other version, there's nothing wrong with that, is 60. And again, I figured this out because I knew angles on a straight line add to 180. I lost the A. There we go. Straight line equal 180. So now I at least have one angle in my triangle. I know this angle, the top here of E is 60, but I'm still missing the other 2 angles. Well, if I go back and look at the left-hand side, I'm trying to get a color I haven't really used yet. We'll go with the dark blue. I need to figure out what this angle right here is. That little left part of D. Well, I know this red box means 90, and I know that that next piece next to it was 30, and those 3 angles together make a straight line. So once again, I can use my 180 fact here and say, okay, well, 180, take away that 90-degree angle that was on the left, and take away that little 30-degree angle that's in between. 90 and 30 add to 120. Well, 180 minus 120 is going to leave me with 60. So this angle, this blue angle right here, I got another 60-degree angle. And again, I didn't know that, so I'm going to jot it down. So the measure of angle, we can call that EDC or CDE. I'm going to go with EDC equals 60. And it's for the same reasoning as up above. Since angles on a straight line equal 180. So I now know 2 angles in that triangle, 60 and 60. I'm left with one final angle left that we need to go back and find. This angle over here in the corner. Well, if I look at that orange triangle that I had before, we said angles in a triangle have to add to 180. I know 60 and 60, so one more time I can talk about 180 here. 180, oh, ignore that. Minus 60 minus 60. Well, 60 and 60 give me 120. 180 minus 120 also gives me 60. So that third and final angle that I was missing, this angle right here, that angle is also 60. So I'm going to jot that down. Measure of angle. That could be ECD or DCE. I'm going to go with DCE is 60. Since angles in a triangle equal 180. So all of that work, and now we can actually answer the question, all right? Make sure you don't just stop here and say, yes, I figured everything out. Well, you did, but we didn't actually answer the question yet. The question from up above said, determine whether ADC is scaling, isosceles, or equilateral. Well, if we go through and look at our vocab words again, scaling meant no congruent sides, which means no congruent angles. Well, I have 60, 60, and 60. They're all the same, so it's not scaling. Isosceles only has 2 congruent angles. Well, I have 3, so therefore, this triangle must be equilateral because it has 3 congruent angles. So that's the final sentence that we do have to jot down. Hopefully you have some space left. I might go into the summary box here. Hopefully you don't, so that you can go back and write your own summary after class. So the last thing I'm going to jot down is triangle DEC equals, or I don't want to say equals, sorry, is equilateral since it has 3 congruent angles. So again, this is a very common type of problem that you might see where you're given a lot of information and you have to work your way through to determine what kind of triangle you're actually looking at. And it all goes back to the number of congruent angles or sides that it has. So if any of this was unsure or didn't make sense to you, please see your teacher and we'll definitely go over it with you. We'll give you some more examples. But once you have this down, again, I apologize for another long video here. Try those practice problems and then get going on that CFU. See you next time.